We have all seen the famous illustrations of the Milky Way, with a little arrow pointing to a spiral arm saying, "You are here." But those images are a lie. If the galaxy were actually drawn to scale, that arrow would be pointing at nothing. The truth is, our entire solar system is smaller than a single atom compared to the body of the galaxy. To understand our place, we must strip away the bright glow of the artistic renderings. We're about to visualize the true emptiness that surrounds us, reveal why finding Earth from the outside would be like finding a specific grain of sand in the Sahara, and explore what it truly feels like to be this small in something so grand. If you want to find your true coordinates in the cosmos, hit that like button and subscribe. Now settle in, relax, we begin. Tonight, let us start with a simple experiment. Imagine you are standing in a pitch-black field. Above you, the sky is thick with light. You see the band of the Milky Way stretching like spilled milk across the dark. It looks dense, it looks crowded. It feels like we are part of a swarm, a bustling city of light where neighbours are just next door. But this is a trick of the light. Your eyes are deceiving you. The stars you see are not neighbours. They are distant lighthouses separated by oceans of nothingness so wide that light itself takes years to cross the gap. We're accustomed to maps on Earth. On a map of the world, an inch might represent 100 miles. We understand that scale. We can drive it. We can fly it. But a map of the galaxy is different. If we shrank the sun down to the size of a grain of sand, the nearest star would not be next to it. It would be another grain of sand 4 miles away. And in between them, nothing. Just 4 miles of empty, silent air. We live our entire lives trapped on that first grain of sand. We fight our wars, we build our cities, and we dream our dreams, all while floating in a bubble of isolation that is hard to comprehend. For centuries, humanity thought the Earth was the centre of everything. Then we realised we orbit the Sun. Then we realised the Sun is just one of billions. But even now, we struggle to feel the true size of that number. We say 100 billion stars as if it is just a statistic. But to the galaxy, we are dust. We have spent decades measuring the light from distant candles to build a three-dimensional model of our home. And what we found is that the Milky Way is bigger, looser, and more mysterious than we dared to imagine. It is not a rigid disk. It is a warped, twisting river of stars, and we are drifting in the suburbs, far from the chaotic downtown of the galactic core. Over the next hour, we are going to travel that distance. We will start at the edge of our own atmosphere and push outward, past the planets, past the silence of interstellar space, and into the crushing gravity of the galactic centre. We will see the invisible structures that hold it all together and the monsters that lurk in the dark. We are going to measure our insignificance. But in doing so, we might find a strange kind of comfort, because to be this small, in a universe this vast, means that our problems, our worries, and our fears are small too. We are just travellers on a pale blue dot, drifting through the beautiful dark. Let us look at the scale of the illusion and find the truth underneath. To understand how small we are, we must first define what home really means. We tend to think our home ends at the atmosphere, or perhaps at the orbit of the moon. If we are feeling generous, we might say the solar system ends at Pluto, but the true boundary of our existence is much, much further away. And it is not a line drawn on a map. It is a physical wall. Our sun does more than just light our days. It breathes. And then, on a day in August 2012, the wind stopped. The probe had not hit a wall of stone. It had hit a wall of pressure. It reached the place where the strength of our sun finally fails. This is the heliopause. It is the moment where the solar wind, exhausted after travelling billions of miles, crashes into the thin, cold gas of interstellar space. Imagine standing on a beach where a river flows into the ocean. The river is our sun's wind, the ocean is the galaxy. At the boundary, the waters churn and mix. It is a turbulent, chaotic frontier. When Voyager crossed this line, the temperature changed. The density of the space around it changed. The sound of the sun faded, replaced by the humming static of the space between stars. This is the true property line of our solar system. Inside, we are part of a family, held together by the gravity and the wind of a single star. Outside, we are in the wild. The distance to this boundary is staggering. It is more than 100 times the distance from the Earth to the Sun. Light takes roughly 18 hours to reach it, And yet on the scale of the Milky Way, this entire bubble, this massive sphere that contains everything we have ever known, is invisible. If you looked at the galaxy from the outside, you would not see our heliosphere. You would not even see the sun as distinct from its neighbours. We have stepped off the front porch. We have opened the gate. Now, we must turn our backs on the warmth of the sun and look into the deep, frozen abyss that lies beyond. We are entering the Oort Cloud, the graveyard of ancient ice, and the true beginning of the Great Dark. We have left the wind of the sun behind, but we have not yet left the gravity of our star. We are drifting into the most desolate, mysterious region of our cosmic address. It is a place that no human eye has seen, and no spacecraft has ever reached. It is called the Oort Cloud. Imagine a sphere, a bubble of ice so large that it swallows the entire solar system thousands of times over. This is not a cloud like the ones you see in the sky, fluffy and white. It is a ghostly shell of frozen debris. It is made of billions of comets, icy rocks, and sleeping mountains of slush that have been drifting here since the birth of the sun. These are the leftovers. When the planets formed 4 billion years ago, violent gravity kicked these icy bodies out of the nest. They were banished to the very edge of the abyss, caught in a delicate balance. They are too far away to feel the warmth of the sun. Out here, the sun is just another bright star in the black sky. But they are still tethered by the thinnest thread of gravity. To cross this region is a journey of mind-bending duration. If you were travelling on Voyager 1, moving at 17 kilometers per second, it would take you 300 years just to reach the inner edge of this cloud. But to cross it, to sail from the inner shore to the outer boundary, it would take 30,000 years. That is the scale of our isolation. We are surrounded by a 30,000-year ocean of ice and silence. It is quiet here. The objects in the Oort Cloud are not crowded together like asteroids in a movie. They are lonely wanderers. You could fly through this cloud for a millennium and never see a single comet. They drift in the dark, separated by distances so vast that they likely never touch, never collide, never interact. They just wait. Occasionally a passing star might drift too close, or the gravity of the galaxy itself might nudge one of these sleepers. Then, and only then, does one of them fall. It begins a long, slow dive toward the warmth of the inner solar system, waking up to become the comets we see streaking across our night skies. Every comet you have ever seen is a visitor from this frozen prison. But for us, the Oort Cloud serves as a marker. It is the true edge of the sun's domain. Once we pass this shell, the gravity of our home star becomes meaningless. It loses its grip. The thread snaps. Beyond this point, there is no up, no down, no centre. There is only the deep. We are entering interstellar space proper. The distances here are no longer measured in miles or kilometres. Those numbers become too large, too clumsy. We must switch to a new language, the language of light. And as we leave the last icy sentinels of the Oort Cloud behind, we look forward into the gap. We are about to cross the great divide between us and the next sun. It is a void so empty that the human mind instinctively rejects it. But we must face it. We must measure the silence. We have now left the Oort Cloud. We are in the deep water. This is interstellar space. When we look at sci-fi movies, we see ships dodging asteroids, flying through colourful nebulae, and jumping from star to star in a matter of minutes. It makes the galaxy feel crowded. It makes it feel like a forest where the trees are touching. But the reality is much more unsettling. The galaxy is not a forest. It is a void. The density of stars in our neighbourhood is so low that it defies human intuition. To understand this, we need to shrink the universe down to a size we can hold in our hands. Imagine that our sun, that massive ball of fire 1 million kilometres wide, is the size of a ping-pong ball. Now, place that ball on a table in the middle of New York City. The Earth is a speck of dust just a few feet away. Jupiter is a small marble a block down the street. But where is the next star? Where is the nearest neighbour to our ping-pong ball sun? Is it in the next building? Is it in the next neighbourhood? No. If our sun is a ping-pong ball in New York, the next nearest star is another ping-pong ball in Atlanta, Georgia. Between them, there is nothing. No buildings, no air, no roads. Just 700 miles of absolute emptiness. This is the true texture of the Milky Way. It is not a solid object. It is a ghost. It is composed almost entirely of the space between things. In this gap, The vacuum is near perfect. On Earth, the air you breathe is thick. In every cubic centimetre of air, the size of a sugar cube, there are billions upon billions of molecules bouncing off each other. But out here, in the silence between the stars, that same sugar cube of space contains maybe one atom, maybe two. It is so empty that if you shouted, there is no medium to carry the sound. If you waved your hand, you would push against nothing. It is a stillness that has lasted for billions of years. And yet, this silence is not dead. It is waiting. This empty space is the canvas upon which the galaxy is painted. It is filled with faint invisible magnetic fields that stretch like spiderwebs across the dark. It is washed by the light of distant monsters. As we drift through this void, looking back, our sun has vanished. It is just another point of light, indistinguishable from the thousands of others. We are truly alone. But ahead of us, a new light is growing brighter. It is a red, unblinking eye in the dark. We are approaching the shore of the next island. We are approaching the Alpha Centauri system. We have arrived at the nearest shore. To the naked eye on Earth, this looks like a single bright point in the southern sky. We call it Alpha Centauri. But as we get closer, the illusion shatters. This is not one star. It is a family of three, locked in a complex gravitational dance. First, there are the two primary stars. They are bright, majestic, and similar to our own sun. They swing around each other every 80 years, a binary waltz of nuclear fire. But they are not our destination. We must look further out, to the lonely outlier of the group. Drifting far from the main pair is a small, dim ember. This is Proxima Centauri. It is the closest star to Earth, yet it is so faint that you cannot see it without a telescope. It is a red dwarf, the most common type of star in the universe. It is barely larger than Jupiter, a dense, cool sphere of glowing gas that burns its fuel with miserly slowness. Our sun will die in a few billion years, but Proxima will burn for trillions. It will be watching long after the rest of the universe has gone dark. Orbiting this dim red bulb is a world. It is a planet roughly the size of Earth, huddled close to the star for warmth. It sits in the habitable zone, where water might exist as a liquid. But this is not a second Earth. If you stood on the surface of Proxima b, the sky would not be blue. It would be a permanent hazy twilight. The star would hang in the sky, huge and red, never setting, never rising. The planet is likely tidally locked, meaning one side faces the heat forever, while the other is frozen in eternal night. Standing here, bathed in that ruddy infrared glow, you would feel a profound sense of distance. You are 4 light years from home. To a beam of light, that journey takes 4 years. But to us, with our fastest chemical rockets, it is an abyss. If Voyager 1 was headed here, which it is not, it would take over 70,000 years to arrive. That is the span of human history, repeated 10 times over. And remember, this is just the house next door. This is the closest neighbour we have. In the grand scale of the Milky Way, we have barely stepped off our doormat. We have explored one star system out of hundreds of billions. We have crossed 4 light years out of 100,000. The scale is about to explode. We are pulling back now, leaving Proxima behind, leaving the sun behind, to look at the structure of our local neighbourhood. We are entering the Orion Spur. We are pulling back now. We are moving faster than the speed of light, zooming out until the Sun and Alpha Centauri blend together. They become a single, indistinguishable pixel of light. As we widen our view, we start to see the neighbourhood we actually live in. For a long time, we told ourselves a grand story. We thought our solar system resided in one of the majestic, sweeping arms of the Milky Way, a main artery of the galaxy. We wanted to be on the highway. We wanted to be downtown, but the universe does not care about our vanity. As we look down at our location from above, we see the truth. We're not in a major spiral arm. We're in a splinter. We're in a bridge. Astronomers call it the Orion Spur. Imagine 2 massive rivers of light, the Sagittarius arm and the Perseus arm, wrapping around the galaxy. These are the major highways, thick with billions of stars glowing with intense radiation. And we're stuck in the quiet space between them. We're on a small diagonal connecting road that links the 2 giants. It is a cosmic backwater, a quiet suburb, and perhaps that is lucky. The major arms are chaotic places. They are dense with exploding stars and dangerous radiation. Out here in the Spur, things are calmer. We have room to breathe. But calm is a relative term. Even this minor bridge is titanic. The Orion Spur is 3,000 light-years across and 10,000 light-years long. It is a structure so vast that if you crossed it at the speed of light, civilization on Earth would rise and fall a dozen times before you reach the other side. This is the home of the constellations you know. When you look up at the winter sky and see the belt of Orion, or the bright blue blaze of Rigel, or the red warnings of Betelgeuse, you are looking at our local neighbours in the Spur, and nestled within this structure is something beautiful. Just over 1,000 light-years away sits the Orion Nebula. To the eye, it is a fuzzy patch on the hunter's sword. But up close, it is a cavern of glowing gas, a stellar nursery where hundreds of new suns are screaming into existence right now. It is a factory of stars. It reminds us that our neighbourhood is alive. It is churning and building. We feel significant here. This is our territory. This is the sky we named. But we are about to break that illusion completely. We are about to zoom out so far that the Orion Spur, this structure that holds every star you have ever seen with your naked eye, disappears into the noise. We are going to look at the Milky Way not as a collection of stars, but as a single flowing object. We are about to enter the river of stars. We have zoomed out until the Orion Spur is invisible. We are now hovering in the intergalactic void, looking down at the face of our home. From here, the Milky Way does not look like a collection of stars. It looks like a storm. It is a glowing, spiralling whirlpool of light, 100,000 light-years wide. It is suspended in the blackness, silent and majestic. The Greeks looked up at the band in the night sky and saw spilled milk, calling it galaxias. The Romans called it the Via Lactea, the road of milk. But physics tells a more violent story. What you're seeing is a flat disk of gas and dust spinning at incredible speeds. It is thin, fragile and terrified of its own gravity. If it stopped spinning, it would collapse into itself. If it spun too fast, it would tear itself apart. It exists in a perfect, delicate balance between falling in and flying out. And those beautiful spiral arms, the great ribbons of light that wrap around the core, they are not solid structures, they are waves. Think of a traffic jam on a highway. The cars slow down, they bunch up, and they create a dense knot of traffic. Then they speed up and leave the knot behind. The traffic jam itself stays in one place, or moves slowly, even though the cars are racing through it. The spiral arms are cosmic traffic jams. They are regions where gravity has squeezed the gas and stars together. As gas flows into these arms, it gets compressed. It ignites. It births new stars. This is why the arms shine so brightly in blue and white. They are tracing the galaxy's pulse. They are the shock waves of creation moving through the disk. Our sun is currently drifting between these arms, in the quiet, darker waters. But it will not stay there forever. We are moving. The galaxy is moving. Nothing is static. We are drifting on a raft in a river that flows in a circle, and that circle is so large, so incomprehensibly vast, that to complete just one lap takes a geological eternity. We are about to measure the longest year in existence. We measure our lives in trips around the sun. 365 days. It feels long. It feels permanent. But the sun has its own clock, and it beats with a rhythm so slow that mountains rise and fall between the ticks. Right now, our entire solar system is moving at 800,000 kilometers per hour. We are strapped into a gravity-powered carousel racing around the center of the galaxy. But the track is so long that in the entire history of the human species, we have barely moved an inch. It takes the sun roughly 230 million years to complete just one single orbit. This is the galactic year. To understand how small we are, let us rewind the clock one single lap. Let us look at where Earth was the last time we were in this exact part of the galaxy. If you looked down at our planet then, you would not recognize it. There were no humans. There were no birds. The continents you know were mashed together into a single massive supercontinent called Pangaea. The Atlantic Ocean did not exist. The dinosaurs were just beginning to rise. They were small, agile creatures running through forests of giant ferns, completely unaware that they would rule the world for millions of years and then vanish, all within the span of a fraction of a galactic orbit. Since the sun ignited 4.5 billion years ago, we have circled the Milky Way only 20 times. That is it. In the eyes of the galaxy, our star is just a 20-year-old. We are young. We are just getting started, and the next time we return to this spot, the next time we complete a lap, Earth will be older. Humans will likely be long gone or changed into something unrecognizable. The continents will have drifted apart and crashed back together in new shapes. The constellations in the sky will be completely different. We are travellers on a timescale that makes stone look like water. We are drifting through the deep history of the cosmos. But what are we orbiting? What is the anchor that holds this entire spinning disk together? What sits in the centre, heavy enough to swing 100 billion stars around it like toys on a string? We are turning our telescope inward now. We are heading for the downtown district. We are going to meet the monster in the middle. We are leaving the quiet suburbs of the Orion Spur. We are falling inward, travelling 26,000 light-years toward the centre of the map. As we get closer, the sky changes. In our neighbourhood, the stars are lonely points of light. But here, near the core, the sky is on fire. The stars are packed so tightly together that if you lived on a planet here, you would never know true night. The sky would be a blazing tapestry of 1,000,000 suns, bright enough to read a book by, 24 hours a day. The radiation is intense. The magnetic fields are twisted and violent. It is a crowded, chaotic downtown district where stars collide and die with frightening regularity. And sitting in the exact centre of this chaos, ruling over it all, is the king. It has a name, Sagittarius A. But names do not do it justice. It is a supermassive black hole. It is a tear in the fabric of reality. It is a drain in the bottom of the galactic ocean. Imagine taking 4 million of our suns, 4 million spheres of blinding plasma, and crushing them down until they fit inside a space no bigger than the orbit of Mercury. That is the density we are talking about, yes, and it is an object so heavy that it bends space like a bowling ball sitting on a trampoline. It anchors the entire galaxy. For decades we could not see it. It is shrouded in thick clouds of dust that block visible light. But we knew it was there. We watched the stars around it. There is a group of stars near the centre that are moving at impossible speeds. They are whipping around a patch of empty space like race cars on a track. They are orbiting nothing. They are dancing with a ghost. One of them, a star called S2, dives in so close that it reaches speeds of 5,000 kilometers per second, a frantic, terrified sprint to escape the gravity of the invisible monster. This is the engine of the Milky Way. It is quiet right now. It is starving, as astronomers say, because not much gas is falling into it today. But it is not asleep. It is waiting. And if you get too close, if you cross a certain line, the universe stops making sense. You stop being an observer, and you become a memory. We are stepping up to the edge now. We are looking into the eye. We are looking at the event horizon. We are hovering at the edge of the abyss. This is the event horizon. It is the most absolute boundary in the universe. To the human mind, it looks like a sphere of pure vantablack darkness, but it is not a solid surface. It is not a wall. It is a mathematical line in space where gravity becomes stronger than light. Think of a river flowing toward a massive waterfall. As you get closer to the edge, the water moves faster. If you are swimming upstream, there comes a point where the current is moving faster than you can swim. No matter how hard you paddle, you are going backward. You're going over the edge. The event horizon is that point in the river of space. Inside this line, space itself is falling into the hole faster than the speed of light. And since nothing can travel faster than light, nothing can swim back up the waterfall. Not radio waves, not X-rays, not the image of your own face. Everything that crosses this line is gone. It is cut off from the rest of the universe forever. But the most terrifying thing about this place is what it does to time. Gravity here is so intense that it pulls on time just as hard as it pulls on rock. If you were to watch a probe fall into Sagittarius A, you would not see it smash into the centre. You would see it slow down. As it approaches the darkness, its clock ticks slower and slower relative to yours. The light coming from it would turn red, then deep infrared, stretching out like a dying note on a violin. Just as it touches the horizon, the probe would appear to freeze. To your eyes, it would hang there forever, a ghost trapped on the edge of eternity, never truly fading, never truly falling. But for the probe, it crosses the line in a heartbeat. It plunges into the dark, unaware that the universe outside has just fast-forwarded into the future. For a long time, this was just theory. But recently we did the impossible. We turned the entire Earth into a giant eye and took a picture of this ghost. We saw a glowing orange ring, the hot gas swirling around the drain, and in the centre, a dark silhouette. That shadow is the footprint of the monster. It is the silence where gravity wins. We are pulling back now, escaping the grip of the black hole before it is too late. As we retreat, the darkness shrinks, and we are blinded once again by the light of the millions of stars that surround it. We are leaving the singularity and entering the ancient city that hides it. We are entering the bulge. We are moving outward from the black hole, swimming up through the gravity well. As the darkness of the centre recedes, we find ourselves inside a blinding fog of light. This is the galactic bulge. If you look at pictures of other spiral galaxies, you often see a bright glowing yellow ball in the middle. It looks soft. It looks like the yolk of a fried egg, but up close, it is a crowded, frantic metropolis. This is the old city of the Milky Way. The stars here are not like the sun. They are ancient. They are red and orange giants, swelling in their old age, packed so tightly together that the night sky here would be 1,000 times brighter than the full moon. These are the first citizens, the stars that formed when the galaxy was young, long before Earth was even a thought. But for a long time, we thought this bulge was just a sphere, a simple ball of stars. We were wrong. When we used infrared telescopes to peer through the dust, we found a structure that changed our understanding of our home. The Milky Way is not a perfect spiral, it is a barred spiral. Running straight through the middle of the galaxy is a massive rectangular bar of stars. It is 27,000 light-years long. It looks like a giant glowing rod connecting the spiral arms to the core. Think of it like a stirring stick in a cup of coffee. As the galaxy rotates, this bar spins. It acts as a majestic cosmic shovel. Its gravity plows through the gas and dust of the disk, pushing it inward, funneling fuel down into the throat of the black hole. It is the mechanism that keeps the galaxy alive. Without the bar, the black hole might starve. The star formation in the centre might stop. It is a structure of immense power, and yet from our position on Earth, it is hidden behind the dust lanes of the Sagittarius arm. We lived in this house for thousands of years without knowing there was a pillar in the living room. As we rise above this bar, looking down, the galaxy looks like a grand spinning machine. The bar turns, the arms trail behind it, and the black hole waits in the centre. But we're not going back to the spiral arms yet. We're going to go up. We're going to fly vertically out of the flat disk of the galaxy into the high, thin atmosphere that surrounds it. We are going to visit the ghosts that haunt the attic. We are entering the galactic halo. We are now doing something that no human spacecraft has ever done. We are breaking the plane. We are flying vertically, straight up, leaving the crowded disk of the Milky Way behind. As we rise, the galaxy changes shape below us. It stops looking like a river of stars and starts to look like a flat, glowing pancake suspended in the dark. We are entering the galactic halo. If the disk is the bustling city where everyone lives and works, the halo is the vast, quiet wilderness that surrounds it. It is a massive sphere of gas and lonely stars that engulfs the entire galaxy. But it is not empty. Floating here, far above the main action, are the ghosts of the Milky Way. They are called globular clusters. Imagine a swarm of bees. Now imagine each bee is a star, and there are 1,000,000 of them, all packed into a tight, perfect ball. That is a globular cluster. These are the oldest objects in the universe. The stars in the disk below, stars like our Sun, are relatively young. They are rich in metals. They have planets. They are the second or third generation. But the stars in these clusters are ancient. They were born shortly after the Big Bang, before the galaxy had even flattened into a spiral. They are the ruins of the first era of creation. Take Omega Centauri, the king of the clusters. It contains 10 million stars squeezed into a space so small that the average distance between them is a fraction of a light year. If you lived on a planet inside that cluster, the night sky would be blinding white. There would be no dark, there would be no constellations, just a wall of constant starlight. These clusters do not orbit in the flat, orderly circle of the disk. They plunge. They dive through the galaxy like stones dropped into a pond, punching through the spiral arms, swinging around the core and then shooting back out into the lonely halo. They are on wild, eccentric orbits that take millions of years to complete. But as we watch them dive, we notice something wrong. These massive balls of stars are moving incredibly fast. They are swinging around the galaxy with a speed that defies logic. Based on the visible light of the Milky Way, the stars, the gas, the black hole, there isn't enough gravity to hold on to them. At these speeds, Omega Centauri should have flown off into deep space billions of years ago. It should be gone, but it isn't. It is held tight. Something invisible is gripping it. Something huge. We have found the edge of the visible galaxy, but we have just bumped into the start of the invisible one. We are about to meet the ghost that holds the machine together. We are about to see the invisible scaffolding. We have explored the glittering city of stars from the core to the spiral arms, but we have a problem that kept astronomers awake for decades. The city should not exist. According to the laws of physics, the Milky Way is spinning too fast to hold itself together. Imagine a child's merry-go-round spinning in a playground. If you spin it gently, the children can hold on easily. But if you attach a motor and spin it at 1,000 miles per hour, what happens? The grip of the children fails. They are thrown outward by the centrifugal force. The galaxy is that merry-go-round. When we measured the speed of the stars at the edge of the galaxy, we expected them to be moving slowly, just like planets far from the sun move slower than planets close to it. But they are not. The stars on the outer rim are racing through space at nearly the same speed as the stars in the centre. At these speeds, the gravity of the stars and gas we can see is nowhere near strong enough to hold them. The galaxy should be tearing itself apart. The stars should be flinging off into the void like stones from a sling. But they don't. The galaxy holds its shape. It spins majestically, calm and intact. This means there is something else there. Something invisible. Something heavy. We call it dark matter, but a better name might be the invisible scaffolding. Imagine looking at a suspension bridge at night. You can see the lights on the cars, you can see the illuminated road, but you cannot see the steel cables in the dark. If you didn't know about the cables, you would think the cars were floating by magic. Dark matter is the steel cable of the universe. It is a vast, invisible halo that engulfs the entire Milky Way. It extends far beyond the furthest stars, creating a massive, invisible sphere. We cannot see it. We cannot touch it. It passes right through the Earth, right through your body as if you were made of mist. It does not interact with light or electricity. It only interacts with gravity. And there is so much of it. For every ounce of normal matter, every star, every planet, every cloud of gas, every human being, there is roughly 5 times as much dark matter. This is the humbling truth of our position. We thought we were the main event. We thought the stars were the galaxy. But the stars are just the decoration. They are just the Christmas lights strung up on a massive invisible tree. The reality of the Milky Way is this dark, silent structure that we are only just beginning to map. We are living in a house we cannot see, and we are not alone in it. While the dark matter holds the galaxy together, there are other things drifting in the dark, lost siblings of our own sun. Over time, the gravity of passing clouds and the sheer rotation of the Milky Way tore the nursery apart. It was like blowing on a dandelion. The seeds scattered, the cluster dissolved, the siblings drifted away, pushed by the gentle currents of the galactic river. Some sped up, moving ahead of us in the orbit. Others lagged behind. Some were kicked up high above the disk, others sank low. Today, they are lost. We have spent years hunting for them. It is a forensic search of cosmic proportions. We analyze the chemical DNA of stars, the specific ratio of elements like iron and barium in their atmosphere. If the ratio matches the Sun exactly, we know they came from the same cloud. They are blood relatives, and we have found them. About 110 light-years away, in the constellation of Hercules, there is a star. To the naked eye, it is invisible, but through a telescope, it looks just like the Sun. It is the same size. It is the same temperature. It is made of the exact same stuff. It is our big brother. We believe there are thousands more out there, hiding in the crowd of the Milky Way, indistinguishable from strangers until we look close enough. It is a haunting thought. We look up at the night sky and feel small and isolated. But the truth is, we are surrounded by family we will likely never meet. They are lighting up their own planets, warming their own worlds, perhaps casting light on other eyes that look back at us, wondering where they came from. We are part of a diaspora. The Sun is just one seed that floated this way, but not everything in the galaxy is a family reunion. Some objects are not creators, they are destroyers. As we look deeper into the history of our galaxy, we find that the Milky Way itself has a dark secret. It didn't just grow, it ate. We're about to investigate the crime scene. We're looking at the cannibal galaxy. We tend to think of galaxies as islands, isolated cities of stars that float peacefully in the void. But in the deep universe, big fish eat little fish, and the Milky Way is a very big fish. For a long time, we looked at the beautiful symmetry of our spiral arms and assumed they formed that way naturally, like a flower blooming. But when we started mapping the precise motion of millions of stars, we found something disturbing. Most stars in the galaxy move in a polite, orderly circle, like cars on a racetrack. But there are groups of stars that are breaking the rules. They're moving the wrong way. They're diving through the disk at steep angles. They're not locals, they're immigrants. These are the debris of galactic collisions. Billions of years ago, a smaller galaxy, something roughly the size of the Small Magellanic Cloud, crashed into us. It didn't survive. The immense gravity of the Milky Way caught it, tore it apart, and digested it. The stars of that lost galaxy are still here. They are mixed in with our own, like red dye swirled into a bucket of white paint. They form long, invisible rivers of foreign stars flowing through our neighbourhood. We call them stellar streams. They are the crumbs left over from a meal, and the feeding hasn't stopped. Right now, at this very moment, we are eating. There is a small galaxy called the Sagittarius dwarf. It is currently crashing through the outer disk of the Milky Way, on the other side of the galactic centre. But it is not a clean fight. Our gravity is stripping it bare. We are pulling long streamers of stars off its back, wrapping them around the Milky Way like ribbons on a maypole. Eventually, the Sagittarius dwarf will cease to exist. Its stars will simply become our stars. Its history will be erased, absorbed into the conqueror. This is how we got so big. We are a patchwork monster. We're a graveyard of smaller galaxies that got too close, and this violence has consequences. These collisions don't just add mass, they warp the shape of the house itself. The impact of the Sagittarius dwarf is ringing through the galaxy like a bell. It has created a distortion that we're only just beginning to map. We're about to look at the scars of this battle. We're moving to the edge of the disk to see the warp. If you bought a model of the Milky Way at a toy store, it would likely be a flat plastic disc. It would look like a frisbee or a dinner plate, perfectly level and smooth. But if that model were actually accurate, you would probably try to return it. You would think it had melted in the sun. We have discovered that the galaxy is not flat. It is broken. Imagine taking a vinyl record and twisting it in your hands. One side curls up and the other side curls down. That is the true shape of our home. It is warped. For decades we missed this because we are stuck inside it. It is hard to see the curvature of the forest floor when you are an ant crawling on a single leaf. But when we mapped the position of the Cepheid variables, bright pulsing stars that act as cosmic mile markers, we saw the pattern emerge. The outer edges of the Milky Way are bent. On one side of the galaxy, the stars are flaring upwards, curving thousands of light years above the main plane. On the opposite side, they are drooping down into the dark. Why? It is the echo of violence. Remember the Sagittarius dwarf galaxy we just mentioned, the one we are currently eating? As it punches through the disk, it acts like a rock thrown into a pond. It creates a ripple. But because the galaxy is spinning, that ripple doesn't just spread out in a circle, it spirals, it twists. We are surfing on a wave of gravity that was started billions of years ago. This warp is immense. If you look at the universe on the grandest scale, you expect everything to be expanding. We have known for a century that the universe is growing, pushing galaxies apart from one another like dots on a balloon being inflated. In a simple universe, every galaxy should be flying away from every other galaxy. But the Milky Way is not following the script. We are moving in the wrong direction. If you subtract the expansion of the universe, you find that our galaxy, and Andromeda, and thousands of our neighbours are all streaming in a single line. We're moving at an astonishing speed, 600 kilometers per second. We're sliding sideways across the universe. Something is pulling us. Astronomers call this the peculiar motion. It is a polite way of saying that something huge has caught us in its net. We are flowing like water down a drain, heading towards a specific point in the sky located between the constellations of Centaurus and Hydra. For decades, we tried to point our telescopes at this spot to see what was there. We expected to see a monster galaxy, or a black hole the size of a universe. But when we looked, we saw nothing. We saw dust. By a cruel cosmic joke, The thing that is pulling us lies directly behind the thickest part of the Milky Way's own disk. It is hidden behind the curtains of our own home. Astronomers call this region the zone of avoidance. It is the blind spot of human knowledge. But gravity cannot be hidden by dust. It passes through walls, and by mapping the way thousands of other galaxies are moving, watching how they speed up and slow down, we have been able to sketch the ghost behind the curtain. We call it the Great Attractor. It is a gravitational anomaly of terrifying power. It is a concentration of mass equivalent to tens of thousands of galaxies, all concentrated in a small volume of space. It is not a black hole. It is likely a massive tangle of galaxies, clusters, and dark matter, a knot in the cosmic web so dense that it dictates the flow of the universe for hundreds of millions of light years around it. We are rushing towards it, but the strange tragedy is that we will never reach it. The expansion of the universe is accelerating. The ground beneath our feet is stretching. Before we can cover the distance to the Great Attractor, the space between us will grow too wide. The horizon will recede faster than we can sail. We are chasing a mirage. We are being pulled by a ghost we will never touch. But let us stop looking at the horizon for a moment. Let us look at the immediate space around us. We have talked about the galaxy and the flow of the universe, but we skipped over something strange right in our own backyard. We need to talk about the emptiness immediately surrounding the sun. We need to talk about the bubble. When we look up at the night sky, we see thousands of stars. The view is crisp. The view is clear. We assume this is just how space looks. We assume the void is transparent. But we are lucky. We are looking out through a window that was smashed open for us. We are currently travelling through a massive hole in the galaxy. Astronomers call it the local bubble. Imagine a dense forest thick with fog and trees. It is hard to see more than a few feet in front of you. Now imagine a bomb goes off in the middle of that forest. It knocks the trees flat. It blows the fog away. It creates a circular clearing where the air is still and the view is perfect. That is where we are. About 14 million years ago, a chain of supernovae went off nearby. Not one, but 15 or 20 massive stars exploded in a rapid-fire sequence. It was a cosmic artillery barrage. These explosions did not destroy the galaxy, but they carved it. The shockwaves slammed into the cold, dense gas of the interstellar medium and pushed it outward like a snowplow clearing a road. They created a cavity, a bubble of hot, thin gas roughly 1,000 light-years wide. Inside this bubble, space is incredibly empty. The density of gas here is 10 times lower than the galactic average. It is a vacuum within a vacuum. But the most fascinating part is that we are not originally from here. The sun did not create this bubble, we just drifted into it. About 5 million years ago, our solar system floated right through the wall of this cavity. We entered the clearing, and for the entire history of the human species, from the first ape that stood upright to the astronaut walking on the moon, we have been looking at the universe from inside this protected empty shell. This bubble is not just a void though, it is a factory. The gas that was pushed away by those explosions didn't disappear. It piled up on the edges. It formed a dense, expanding wall of material. And in that wall, new stars are being born. The gravity of the shockwave compressed the gas until it ignited. So we're sitting in a quiet, empty room surrounded by a ring of fire. And this ring has a name. It is a structure of bright, young stars that circles our entire sky, framing our view of the heavens. We're about to look at the Gould Belt. If you could fly out of the solar system and look back at our neighbourhood from a few thousand light years away, you would see something that looks impossible. You would see a ring of bright blue stars tilted at a 20-degree angle to the rest of the galaxy. This is the Gould Belt. It looks like a giant glowing hula hoop floating in the disk of the Milky Way. It is about 3,000 light years wide, and it contains almost every major bright star you learned as a child. When you look at the constellation of Orion, or the tail of the Scorpion, or the Southern Cross, you are tracing the edge of this ring. These stars are not random wanderers, they are siblings. They were all born around the same time, roughly 30 to 50 million years ago, from a massive wave of star formation that swept through our part of the galaxy. It is a stunning realization. We think the night sky is deep. We think we are looking into the infinite, but in reality most of the naked eye stars we see are just the furniture in our own living room. They are a local clique, a specific ring of young, hot stars that happen to be passing through our corner of space. The sun is currently drifting through the interior of this ring. We are the old man walking through a party of teenagers. These stars are young, volatile, and destined to die young. Betelgeuse, Rigel, and Teres, they will all explode in the blink of a cosmic eye. But our sun will keep plodding along, watching them burn out one by one. This structure reminds us that the galaxy is clumpy. It is not smooth. It has weather. It has structures. It has history. But as we look at this ring of fire, at these thousands of young suns and the billions of older stars behind them, a question forces its way into our minds. We have measured the scale. We have seen the chemical ingredients for life everywhere. We have found planets orbiting nearly every star we look at. The math suggests that the galaxy should be teeming with voices. It should be loud. It should be crowded. But when we point our radio telescopes at the Gould Belt, or the Orion Spur, or the Galactic Center, we hear nothing. We hear the hiss of hydrogen. We hear the roar of dying stars. We hear the static of the Big Bang. But we do not hear a greeting. We are about to face the most haunting contradiction in science. We are entering the Great Silence. We are standing on the edge of a cliff, shouting into a canyon, waiting for an echo that never comes. This is the most unsettling fact about our position in the Milky Way. It is not the size. It is not the black hole. It is the silence. Let us look at the math. The Milky Way is 13 billion years old. It contains roughly 400 billion stars. We now know that planets are common. Almost every star has them. Even if life is incredibly rare, even if it happens on only 1 in a billion planets, there should still be hundreds of civilizations out there. And more importantly, there has been enough time. It took humans only a few thousand years to go from stone tools to space stations. In the life of the galaxy, that is less than a heartbeat. If a civilization started just 1 million years before us, a tiny fraction of cosmic time, they should have spread across the entire galaxy by now. They should be everywhere. Their radio signals should be washing over us like the tide. Their megastructures should be blocking the light of stars. But we see nothing. We have scanned the sky for 60 years. We have listened to millions of channels. We have looked for laser pulses, for Dyson spheres, for engines, and the result is a perfect, terrifying zero. This is the Great Silence. It forces us to ask 3 difficult questions. First, are we simply too early? Are we the first ones to wake up in the morning of the galaxy? Perhaps the universe was too violent before now, too full of exploding stars, and we are the first flower to bloom in a calm spring. Second, are we looking at a graveyard? Perhaps civilizations rise constantly, like waves on an ocean, but they crash just as quickly. Perhaps technology itself is a trap, a filter that destroys every species that invents it before they can leave their home rock. Or third, and perhaps most frightening, is the galaxy teeming with life, but they are hiding. Imagine a dark forest at night. You're walking through it, shouting, lighting a fire, making noise. You assume the forest is empty because no one answers, but perhaps the forest is full of eyes. Perhaps the reason it is quiet is because everyone else knows that there are predators in the dark, and the only way to survive is to stay silent. We are the loud children in that forest. We have been broadcasting our location to the stars for a century. We have sent maps. We have sent invitations. If there is anyone out there, they know we are here. And the fact that they haven't answered might not mean they don't exist. It might mean they are watching and waiting. But there is another possibility. Maybe we are just looking in the wrong neighborhoods. Maybe life isn't everywhere. Maybe it can only survive in a very specific thin ring of safety. We are about to map the green zone of the galaxy. We talk about the Goldilocks zone when we hunt for planets, that perfect distance from a star where it is not too hot and not too cold for water to exist. But we rarely talk about the bigger picture. It turns out the galaxy itself has a Goldilocks zone, and we are sitting right in the middle of it. If Earth had been born in a different zip code, we would not be here. Imagine the galaxy as a sprawling city. Downtown, the galactic core is vibrant and bright, but it is also lethal. The radiation levels there are intense. The stars are packed so tightly that a supernova goes off every few centuries, blasting the surrounding worlds with sterilizing X-rays. If Earth orbited a star near the center, our atmosphere would have been stripped away long ago. Life would never have had the stability to crawl out of the ocean. So the center is a dead zone. It is too violent. But the outskirts are no better. As you move to the edge of the galaxy, the stars become sparse. But the real problem is the ingredients. To build a human being, you need carbon, oxygen, and iron. To build a rocky planet like Earth, you need silicon and nickel. Astronomers call these metals, and they are cooked inside massive stars. In the outer rim of the Milky Way, the stars are old and the gas is pristine. It is mostly just hydrogen and helium. There aren't enough heavy elements to build a world like ours. You might get gas giants, but you won't get rocks. You won't get blood. You won't get bones. So the edge is a dead zone too. It is too poor. Life, it seems, can only survive in a thin ring of real estate, a donut-shaped band about 25,000 light-years from the core. This is the galactic habitable zone. It is the cosmic suburbs. It is close enough to the city to have the heavy elements needed for biology, but far enough away to avoid the radiation storms of the downtown district. This realization makes our existence feel even more fragile. We are not just on a lucky planet, we are in a lucky neighborhood. The vast majority of the Milky Way is likely uninhabitable for complex life. We are safe here. But being safe has a downside. It means we are isolated. We have been trying to break that isolation for a century. We have been screaming into the void with our radio towers. But when you measure how far our voice has actually travelled, the result is humbling. We're about to look at the limit of our influence. We're about to measure the radiosphere. We humans love to make noise. For a little over 100 years, we've been leaking radio waves into space. Every television broadcast, every radar ping, every radio song, it all travels outward at the speed of light, moving away from Earth like an expanding bubble of sound. We call this the radiosphere. It is our footprint. It is the announcement that we are here. And because it moves at the speed of light, it feels incredibly fast. In 1 second, our signal circles the Earth 7 times. In 4 years, it reaches Alpha Centauri. In 10 years, it washes over a dozen stars. We feel loud. We feel significant. But let us place this sphere on the map of the Milky Way. If you look at the entire galaxy, that majestic disk, 100,000 light-years wide, and you try to find the radiosphere, you will have to squint. It is not a roar. It is a whisper. Our radio bubble, containing the entire history of electronic humanity, is a tiny blue dot less than 200 light-years across. On the scale of the galaxy, it is smaller than a single pixel on your screen. If there is an alien civilization on the other side of the Milky Way, looking at us with a telescope right now, they do not see the internet. They do not see cities. They do not hear our music. They see Earth as it was 50,000 years ago. They see a silent green world where humans are just beginning to paint in caves. Our voice has not reached them. In fact, our voice has barely left our front yard. This is the tyranny of the speed of light. It is fast, but the universe is vast. We're trapped in a delay so long that conversation is impossible. Even if we shouted hello to the centre of the galaxy today, the answer would not return for 50,000 years. We are muted by distance, but we are not the only island in the dark. We have spent this entire journey looking at our own galaxy, obsessed with our own home. But the Milky Way is not the only city in the universe. In fact, it is about to have a very violent visitor. We are turning our eyes outward now. We are looking past the edge of our own halo into the deep intergalactic dark. Something is coming. Something beautiful and terrifying and big. We are looking at the Andromeda horizon. We have reached the edge of our vision. If you go to a dark field in the northern hemisphere tonight and look up, you can see something impossible. You can see an object that is outside our own galaxy with your naked eye. Find the constellation of Andromeda. Look slightly to the side. There, hanging in the blackness, is a faint fuzzy smudge. It looks like a thumbprint on the glass of the sky. It looks small. It looks insignificant. But this is the greatest optical illusion in existence. That smudge is not a star. It is not a cloud. It is an island universe. This is the Andromeda Galaxy. It is the Milky Way's big sister. It is a spiral city containing 1 trillion stars, more than double the number in our own home. It is so massive that if your eyes were sensitive enough to see its full width, it would loom over the horizon 6 times wider than the full moon. It would dominate the night, but it is faint because it is far. It is 2.5 million light-years away. When the light hitting your retina tonight left Andromeda, humans did not exist. Gravity has won the battle against expansion here. The 2 sisters are tethered together by an invisible rope, and they are pulling. Every hour you have been alive, Andromeda has moved thousands of miles closer. Every time you look up, that smudge is just a tiny imperceptible fraction larger than it was the night before. It is coming, and it is not going to stop. We're about to watch the slow-motion car crash of the millennium. 4.5 billion years from now, the Earth will likely still be here, though it will be unrecognizable. The sun will be bloated and angry, a red giant nearing the end of its life, having swallowed Mercury and Venus. The oceans may have boiled away, leaving only rock and dust. But if you could stand on that scorched surface, protected by some impossible shield, the night sky would look like a fantasy painting. Andromeda will no longer be a faint smudge in the corner of your eye. It will be a colossus. It will fill the entire horizon, a swirling vortex of 1 trillion stars crashing down on top of us. It will be so bright that it casts shadows on the ground at midnight. The familiar arch of the Milky Way, the band of milk that has defined our sky for human history, will be twisted and broken, its spine snapped by gravity, reaching up to meet the invader. It will look like the end of the world. But here is the strange, counterintuitive truth about galactic collisions. Despite the apocalyptic view, nothing is actually going to hit us. We tend to think of a collision like 2 car crashes, metal crunching against metal. But remember the emptiness we talked about earlier? Remember how the nearest star is a ping-pong ball 700 miles away? Galaxies are not solid objects. They are ghosts. They are made of 99% empty space. When 2 galaxies collide, it is like 2 clouds of smoke passing through each other. It is like 2 swarms of bees flying through the same garden. The swarms mix, but the individual bees rarely touch. The stars will slip past one another in the dark. The odds of the sun physically crashing into another star are essentially 0. We will pass through the heart of the storm physically untouched. But while we won't hit anything, we cannot escape the gravity. Gravity is the invisible hand that reshapes the sky. As the 2 heavy cores swing past each other, they will catch us in a gravitational riptide of unimaginable power. The orderly, flat spiral of the Milky Way will be destroyed. The delicate balance that kept us in the quiet suburbs will be shattered. Our solar system faces 2 potential destinies in this chaos. In one scenario, we are flung outward. The gravity of Andromeda might act like a slingshot, kicking the sun out of the galaxy entirely. We would find ourselves exiled into the deep intergalactic void, drifting alone in the cold dark, watching the merger of the 2 giants from a distance, a lonely spectator to the greatest show in the universe. In the other scenario, we are pulled deep into the chaotic new center. We would fall into the downtown district of the merger, where the radiation is intense and the skies blindingly bright with the light of 1 million neighbors. The collision itself is not a quick event. It will be a slow, silent waltz of destruction that lasts for billions of years. The galaxies will pass through each other, slow down, stop, and fall back together again. And during this dance, the sky will be on fire. While the stars don't hit each other, the gas clouds do. Huge nebulae, light years wide, will slam together at millions of miles per hour. This compression will trigger the greatest baby boom in the history of our local universe. The sky will light up with millions of new bright blue stars, a final burst of fireworks to celebrate the union. Supernovae will go off like flashbulbs, stringing the night with explosions, and when the dust settles billions of years later, the 2 beautiful spirals will be gone. The pinwheel shapes will be erased. The chaos will calm down into a dull, stable quiet. In their place will be a single, massive, football-shaped blob of stars. A giant elliptical galaxy. Astronomers have already named this future child. They call it Milkomeda. It will be a red, tired galaxy. The gas will be used up. The star formation will stop. It will simply exist. A massive ball of aging stars floating in the dark. It is the destiny of our home. We are not a permanent fixture. We are just a temporary arrangement of stars waiting to be reshuffled. But even this merger, as titanic as it seems to us, is just a local event. It is just 2 specks of dust sticking together in a much larger room. To understand where we truly are, we need to step back one more time. We need to see the neighborhood that contains both of us and thousands more like us. We are entering the superstructure. We are entering Laniakea. We are zooming out one more time to a scale that is almost impossible to hold in the human mind. We are leaving the local group behind. The Milky Way and Andromeda, those 2 titans that seemed so large just a moment ago, become 2 inseparable, microscopic dots of light. lost in a sea of thousands of other galaxies. For a long time, we thought these galaxies were just scattered randomly, like coins tossed on a floor. We looked at the sky in 2 dimensions, mapping where things sat, and assumed that was the whole story. We thought they sat where they landed, static and disconnected. But in 2014, we realized we were wrong. We weren't looking at a floor. We were looking at a map of currents. A team of researchers decided to ignore where the galaxies were and focused instead on where they were going. We mapped the subtle, invisible movement of 8,000 galaxies in our neighborhood. We subtracted the expansion of the universe, that constant outward push, to see the true underlying motion. And suddenly, a pattern emerged from the chaos. We saw a flow. The universe is not a static painting. It is a moving, living river system. Imagine a mountain range during a rainstorm. The water hits the peaks and runs down into the valleys. It gathers into streams, then rivers, all flowing toward the lowest point. This creates a watershed, a massive region of land where every drop of water shares the same destiny, all headed for the same ocean. The universe has watersheds too, but instead of water, it flows with galaxies, and instead of valleys, it flows into gravity wells. We discovered that our galaxy, along with 100,000 others, is sliding down the side of a gravitational mountain. We're all flowing together, caught in a current we cannot feel but cannot escape. We are drifting like drops of rain toward the same deep valley in the dark, a central gravitational basin that anchors us all. We named this continent of light Laniakea. In the Hawaiian language it means immeasurable heaven, and the name fits. Laniakea is 520 million light-years wide. It is a structure of such colossal proportion that light itself, the fastest thing in existence, would take 500 million years just to cross from one side to the other. It is not a solid object. It is a glowing, fibrous web of light, bending and twisting through the void. It looks like the root system of a giant tree, or the delicate capillaries of a lung. It is composed of massive filaments of galaxies, long threads of light that stretch across the darkness, all converging toward that mysterious Great Attractor we spoke of earlier. And somewhere in one of those thin, fragile filaments, on the very outskirts of the flow, is the Milky Way. We are not in the center of this continent. We are on the fringe. We are just a speck of dust in the immeasurable heaven, drifting along a minor tributary of the great river. But Laniakea is not the entire universe. It is just our local patch of ground. Just as a watershed on Earth is bordered by a mountain ridge that separates it from the next valley, Laniakea has edges. There are invisible gravitational divides in deep space. If you cross them, the flow changes. The galaxies on the other side are falling away from us, sliding down into a different valley, toward a different attractor. If we look past the edge of Laniakea, we see these other giants. We see the Perseus-Pisces Supercluster, a wall of galaxies almost as large as our own. We see the Shapley Supercluster, a monster in the deep distance. We see the Coma Supercluster. They are all massive, all distinct, all holding their own 100,000 galaxies, glowing like distant cities on the horizon. And when you stitch them all together, when you zoom out until Laniakea itself becomes just a pixel, the structure of the universe reveals itself to be something frighteningly organic. It looks like a sponge. It looks like a spiderweb glistening in the morning dew. It looks, unnervingly, like the neural network of a human brain. We're about to look at the architecture of everything. We're entering the cosmic web. We have zoomed out as far as the mind can go. We are now looking at the universe from the perspective of a god. At this scale, the individual galaxies, the Milky Way, Andromeda, even the giant clusters containing thousands of worlds, vanish completely. They are too small to be seen as objects. Instead, they become texture. They become a fine, glowing dust suspended in the abyss. And what we see is not a random cloud. It is not a chaotic mess of scattered light. It is a structure of haunting, deliberate geometry. The universe looks like a sponge. It looks like a spiderweb glistening in the dark. It looks, unnervingly, like the firing neurons of a human brain. This is the cosmic web. It is the largest pattern in nature. It is composed of long, thin filaments of light, massive bridges made of millions of galaxies strung together like pearls on a string. These filaments stretch for hundreds of millions of light years, twisting and connecting the superclusters together in a vast three-dimensional network. Some of these structures are so large they break our understanding of physics. There is the Sloan Great Wall, a barrier of galaxies 1.3 billion light-years long. There is the Hercules Corona Borealis Great Wall, a structure so immense that it takes light 10 billion years just to cross it. These are the veins of the cosmos, pulsing with the flow of gravity and matter. But the web is not defined by the light, it is defined by the dark. Between these threads, there is nothing. The universe is dominated by massive spherical regions of emptiness called cosmic voids. These are the bubbles in the sponge. They are the silent rooms between the noisy walls. Some of them, like the Butter's Void, are nightmares of isolation. Imagine a sphere of space 250 million light-years wide. It should contain 10,000 galaxies. Instead, it contains 60. If the Milky Way had been inside the centre of the Butter's Void, we would not have known there was a universe outside of us until the invention of powerful telescopes in the 1920s. If you looked up from a planet in that void, the sky would be pitch black. You would see no stars, no bands of light, no neighbours. You would be surrounded by a darkness so absolute that human sanity might not survive it. We live in one of the threads. We are stuck in the fibre, huddled together with the other galaxies for warmth. But the most humbling part of this picture is realising what the web actually is. The galaxies we see, the bright lights, the stars, the gas, are just the decoration. They are just the dewdrops clinging to the spider's silk. The silk itself is invisible. The web is built of dark matter. Gravity built this structure in the dark billions of years ago. It formed the skeleton of the universe, the invisible scaffolding that holds everything in place. It carved the channels and dug the basins. Normal matter, the stuff you, me, the Earth and the stars are made of, is just the foam that floated into the low points. We are just the bioluminescent algae tracing the shape of a dark, invisible ocean. This is the largest thing in existence. It is the map of reality. But as we look at this majestic web stretching out to the edge of the observable universe, we hit a hard, cold wall. We can see the structure, but we can never explore it. The map is teasing us. We are trapped in our little corner of the web by a jailer that never sleeps. We are about to face the speed of light cage. Here is the hardest truth to swallow. We have spent this hour travelling outward. We move from the Earth, to the Sun, to the galaxy, to the supercluster, and finally to the cosmic web. We built a map of a universe that is 93 billion light-years wide. We feel like explorers standing on the edge of a vast open ocean, ready to set sail. We feel like if we just had better engines or more time, we could go anywhere. But we are not explorers. We are prisoners. The universe is playing a cruel trick on us. It shows us a horizon that we can never reach. It dangles the beauty of the cosmos in front of our eyes, but places it behind a wall of glass that can never be broken. We know that the universe is expanding. Space is being created between the galaxies every second. It is not that the galaxies are flying through space like rockets. It is that the stage itself is stretching. And the problem is, this expansion adds up. The further away a galaxy is, the more space is being created between us and it. Eventually, you reach a geometric tipping point. You reach a distance where the space is expanding faster than the speed of light. Think of a runner on a treadmill. The runner is a beam of light sprinting at 300,000 kilometers per second, the absolute speed limit of the universe. The treadmill is space. If the treadmill is moving backward faster than the runner can sprint forward, the runner moves backward. This means there are galaxies in the cosmic web that are sending light toward us right now. They are shining brightly, but that light is trying to swim upstream against a current that is too fast. It is losing ground. It will travel for eternity, fighting the expansion, but it will never ever reach Earth. This creates a wall, a cosmic event horizon. And the terrifying statistic is this: 94% of the galaxies we can see in our telescopes are already behind this wall. Read that again, 94%. Almost everything we can see is already lost. If we built a spaceship today that could travel at 99% of the speed of light, a technological miracle, and we left right now, we could never reach them. It doesn't matter how much fuel we bring. It doesn't matter if we freeze ourselves for 1 billion years. We can't outrun the stretching of the road. As we travel toward them, the gap would only get wider. They are gone. They are physically disconnected from our future. So what are we looking at when we look at the deep field images from the James Webb Telescope? We are seeing ghosts. We're watching a movie of a place that has already drifted off the edge of the world. The galaxies we see are mirages of the past, shining from a location that, for all intents and purposes, no longer exists in our reality. And it gets worse, because the expansion is not just happening, it is accelerating. Something is pushing the accelerator pedal down. The horizon is shrinking. Every second you have been listening to this, another star, another galaxy, another potential civilization has slipped across the line. They have sent their final photon, the last bit of light that will ever reach us, and then they have vanished from our potential future forever. We are living in a unique, fleeting moment in cosmic history. We are living in the era where we can still see the neighbours. Billions of years from now, the expansion will be so fast that the other superclusters will fade into the black. The light from the cosmic web will be stretched so thin it becomes undetectable. The sky beyond our local group will be empty. Future civilizations born in that distant era will have a very different astronomy. They will look up and see the Milky Way, and they will see Andromeda, or the merged Milkomeda, but they will see nothing else. They will think the entire universe consists of just one island of stars surrounded by an infinite, eternal void. They will have no way of knowing the cosmic web ever existed. They will have no evidence of the Big Bang. They will think they are alone in a static, dark box. We are the lucky ones. We are the ones who got to see the grandeur before the lights went out. But we are also the ones who have to live with the knowledge of the cage. We are trapped in a shrinking patch of reality, isolated from the rest of creation by the laws of physics themselves. But while we cannot leave, while we cannot touch the stars that taunt us, we are connected to the cosmos in a different way. We cannot go to the furnace, but the furnace came to us. We are about to stop looking at the telescope and start looking at the microscope. We are about to look at the atoms in your hand. We are entering the dust of ancestors. Look at your hand. Turn it over. Look at the veins in your wrist. Look at the skin on your fingertips. It feels smooth. It feels warm. It feels like you. But this is an illusion of ownership. You're not a single solid object created in isolation. You're a temporary gathering of ancient debris. You're a collection of borrowed atoms that have been travelling for eons to meet right here in the shape of a human being. Every atom in your body has a history that stretches back billions of years, and almost none of those atoms were created here on Earth. When the universe began, it was boring. It was a dark, sterile sea of simple gas, mostly hydrogen and helium, with a pinch of lithium. That was it. There was no carbon to build a cell. There was no silicon to build a rock. There was no oxygen to breathe. You could not make a planet, let alone a person. The universe was a blank canvas waiting for paint. To make you, the cosmos had to invent a furnace. It had to invent a way to crush simple atoms until they merged into something new. It built the stars. A star is not just a light in the sky. It is a desperate machine. It is a ball of gas fighting for its life against the crushing weight of gravity. To stop from collapsing, it burns its own heart. It acts as a nuclear alchemist, fusing atoms together to create heat. But this process, this survival mechanism, has a byproduct. It creates ash, and that ash is the stuff of life. The carbon in your DNA, the backbone of every cell in your body, that was cooked in the belly of a massive star that died long before the Earth was even a rumour. For millions of years, that star crushed helium into carbon, preparing the blueprint for biology. The nitrogen in your muscles? It came from the slow, steady winds of dying suns. And the calcium? The white stuff that makes your bones hard enough to walk on and your teeth strong enough to chew? That was likely forged in the explosion of a white dwarf, a dead star that stole too much gas from a neighbour and detonated like a cosmic bomb, scattering its calcified remains across the dark. And then there is the iron. Look at the red blood in your veins. That iron is the ghost of a cosmic murder. Iron is the final element a massive star can create. It is the end of the line. When a star tries to fuse iron, it loses energy. The fire goes out. The gravity wins. In a fraction of a second, the star collapses and screams into the void as a supernova. That iron is the tombstone of a sun, and yet it is the only reason you can breathe today. Every time your heart beats, it is pumping the shrapnel of a cosmic catastrophe through your veins. You're walking around with the wreckage of a billion-year-old explosion inside your chest. But there are elements in your life that even a supernova cannot make. They are too heavy, too complex. Look at the gold in a wedding ring. Look at the iodine in your thyroid. These atoms are so rare because their birth requires violence on a scale that defies imagination. They were born in the collision of two neutron stars. Imagine two dead stars, each the size of a city but heavier than the sun, spiraling around each other. Faster and faster, screaming through the void until they slam together at a significant fraction of the speed of light. In that split second of fire known as a kilonova, they created enough gold to fill an ocean. That gold was blasted across the universe, mixed into a cloud of dust, formed into a planet, mined from the rock by human hands, and ended up on your finger. It is a souvenir from the most violent car crash in physics. We often feel separated from the universe. We look up at it. But we are not passengers in the Milky Way. We are the Milky Way. We are the part of the galaxy that woke up. We are the mechanism by which the universe knows itself. We are the dust that sat up and started asking questions. We are made of dead stars looking back at live ones. But there is one final dimension we must measure. We have measured the distance. We have measured the chemistry. Now we must measure the duration. Because the stars you see tonight are not just far away in space. They are deep in the past. We are about to look at the perspective of time. When you look at a friend standing across the room, you see them as they are right now. The light bounces off their face and hits your eye almost instantly. The gap is less than a microsecond, so small that our brains ignore it. We live our entire lives in this bubble of immediate cause and effect. We live in a world of now. But when you look up at the sky, now ceases to exist. The speed of a light is fast, 300,000 kilometers per second, but it is not infinite. It takes time to push through the dark. This means that looking into space is exactly the same thing as looking back in time. The night sky is not a ceiling painted with static lights. It is a deep, vertical shaft of history. We are surrounded by ghosts. When you look at the moon, you are not seeing it as it is this second. You're seeing it as it was 1.3 seconds ago. You're seeing a slightly younger version of the rock. If an asteroid smashed into a crater on the moon right this instant, you wouldn't know. You would stare at a peaceful grey surface for one whole second before the flash of light finally arrived to tell you the truth. When you look at the sun, the delay grows to 8 minutes. This is a terrifying thought. If the sun simply vanished right now, if it was plucked out of the universe by a giant hand, we would not know. We would still see it shining in the sky. We would still feel its warmth on our skin. The flowers would still turn towards the light. The planets would still orbit its gravity for 8 long minutes, dancing around a centre that was no longer there. We would spend those 8 minutes living in a fool's paradise, blissfully unaware that the darkness was already rushing toward us at the speed of light. We are always living in the past. We are always waiting for the news to arrive. As we look deeper, the lag becomes a chasm. When you look at Jupiter, you are seeing light that left 40 minutes ago. When you look at Saturn, you're peering over an hour into history. But the stars take us into the realm of archaeology. Look at the 3 bright stars of Orion's belt. The light hitting your eyes tonight left those stars during the Middle Ages. You are seeing them as they were when knights were building castles in Europe, and the Maya were building pyramids in America. That light has been streaming through the void for centuries, carrying the image of a medieval star to a modern eye. Look at the Andromeda galaxy, that fuzzy smudge we talked about. You are seeing light that started its journey 2.5 million years ago. When that light left Andromeda, humans did not exist. There were no cities, there was no fire, there were only small, upright apes on the plains of Africa, chipping stones into tools. That light travelled while we discovered fire, while we built empires, while we fought wars, while we invented the telescope, only to end its journey tonight at the back of your retina. This leads to a haunting realization. The universe you see might not exist anymore. Take the pillars of creation, those famous towering clouds of gas in the Eagle Nebula. We see them standing tall and majestic, birthing new stars. But astronomers believe that a supernova shockwave likely toppled them 6,000 years ago. In reality, they are already destroyed. They are dust. But the light of their destruction hasn't reached us yet. We are admiring a ruin that we still think is a castle. Betelgeuse, the bright red star on the shoulder of Orion, is dying. It is wobbling. It could explode tomorrow, or it could have exploded 500 years ago. If it did, the light of that explosion is currently rushing toward us, crossing the dark, and we are just blissfully unaware, staring at a star that is already a corpse. There is no such thing as a universal now. Now is a local illusion. It is a biological trick that only works on short distances. We are isolated in time just as much as we are isolated in space. We can never know what the universe is doing at this exact moment. We can never share a moment with a distant civilization. If we send a message to the center of the galaxy saying hello and they reply immediately, the answer won't come back for 50,000 years. By the time it arrives, our civilization might be dust. We're trapped in a bubble of silence. But there is a beauty in this delay. It means the sky is an archive. It is the ultimate library. If light travelled instantly, the sky would be boring. We would only see the universe as it is today. But because light takes time, we can see the universe as it was in its youth. By building better telescopes, by looking further out, we are digging down into the geological layers of time. We can see the galaxies as they were billions of years ago, small and messy. We can see the first stars turning on. We can look all the way back to the fading glow of the Big Bang itself. We are time travellers. We are standing on the bow of a ship looking back at the wake we left behind. And now we have reached the end of our journey. We have measured the void, we have mapped the dark, we have faced the silence. It is time to ask the final question. What do we do with this feeling? What is the value of being this small? We have reached the end of the map. We have drifted from the warmth of the sun, past the silence of the Oort Cloud, through the crowded spiral arms of the Milky Way, and out into the terrifying vastness of the Laniakea Supercluster. We have stood on the edge of the local void and peered into the abyss where no stars shine. We have measured the universe, and the result is undeniable. We are small. In the grand arithmetic of the cosmos, we are not even a rounding error. We are less than a ghost. If the Earth vanished today, if our entire history, our wars, our art, and our cities were erased in a blink, the galaxy would not notice. The stars would keep burning, the gravity would keep pulling, and the great clock would keep ticking without missing a beat. The Andromeda galaxy would still crash into the Milky Way. The expansion would still push the horizon away. The silence would remain unbroken. For many, this realization brings a cold, hollow feeling. It is a vertigo of the soul. We are raised to believe we are the center of the story. We want to matter. We want to be the main character. To find out we are dust on a random rock in the suburbs of an average galaxy feels like a demotion. It feels like we are screaming into a void that refuses to answer back. But I want you to see it differently. I want you to see our smallness not as a prison, but as a gift. Think of the weight you carry every day. The stress of your job, the regret of the past, the anxiety of the future, the arguments, the bills, the noise. We build these problems up until they feel like mountains. We let them crush us. But when you stand next to a supermassive black hole, or look into the face of the cosmic web, those mountains turn into grains of sand. Those problems do not vanish, but they shrink. They lose their absolute power over you. The universe is too big to worry about the embarrassing thing you said 5 years ago. It is too old to care about your status, your title, or your bank account. The stars do not judge you. The void does not demand perfection from you. Against the scale of eternity, our lives are fleeting sparks lasting less than a microsecond on the cosmic calendar, and that means we are free. If we are just temporary travellers, if we are just tourists in this grand museum, then the pressure is off. We're free to enjoy the spark while it lasts. We're free to make mistakes, to love, to explore, and to be happy, simply because we are here. The universe doesn't need us to be important. It just needs us to be present. And there is something else. Something even more profound than our freedom. The universe is vast, yes. It is 93 billion light-years of fire and ice. It is a machine of unimaginable power, capable of crushing stars and bending time. But as far as we know, it is mostly dead. It is unconscious. The stars do not know they are shining. The nebulae do not know they are beautiful. The black holes do not know they are powerful. A supernova is a spectacular event, but to the universe, it is just physics. It is just heat and pressure acting in the dark. It has no meaning. It has no story until us. You are the rarest thing in existence. You are the universe waking up. You are a collection of atoms that has come together against all odds to look back at the stars and feel awe. You are the mechanism by which the cosmos understands itself. Without you, without us, The universe is just a play with no audience. It is just a room full of masterpieces with the lights turned off. It is just physics doing math in the dark. We give the universe meaning. We give it a name. We look at a ball of burning gas and call it sun. We look at a pattern of dots and call it Orion. We look at the void and feel mystery. We are the bridge between the cold indifference of matter and the warm light of consciousness. We are the mirror that the universe built to see its own face. So the next time you look up at the night sky and feel small, do not be afraid. Do not feel lonely. Smile. Because you are the witness. You are the eyes of the galaxy. And that makes you just as big and just as important as the stars you're looking at. Thank you for taking this journey with me. If this story shifted your perspective, even a little, please hit that like button and subscribe to the channel. It helps us keep the campfire burning in the dark. And tell me in the comments, when you look at the stars, does the size of the universe make you feel lonely or free? Until next time, keep looking up. The universe is waiting.